Imagine standing on the coast and watching hundreds of thousands of tons of garbage being dumped into the ocean. Not plastic, not chemicals, not construction waste. Oyster shells, mountains of them. Day after day, year after year, barges carried discarded shells from restaurants and seafood factories out into the Gulf waters. Before we continue, hit like and subscribe to this channel. Now, keep watching. Many people were furious. Environmental groups called it reckless. Fishermen warned it would destroy marine habitats. Scientists hoped for the best, but privately expected very little. Yet what happened next shocked almost everyone. Because those unwanted shells didn't become underwater trash, they became the foundation of one of the most remarkable ecological recoveries ever recorded. And the story only gets more unbelievable from there. Long before the Shell project began, Florida's Gulf Coast was facing a serious problem. The region once supported vast oyster reefs stretching for miles. These reefs weren't just collections of shellfish. They were living cities beneath the water. Thousands of marine species depended on them. Fish used them as nurseries. Crabs hid within them. Sea turtles fed around them. And the reefs themselves acted as giant water filters. But over decades, pollution, coastal development, overharvesting, and habitat destruction took their toll. Many reefs collapsed. When reefs disappear, the damage spreads. Fewer oysters means dirtier water. Dirtier water means fewer seagrass beds. Fewer seagrass beds means fewer fish. The entire system begins to unravel. Scientists knew something had to change. The question was, how? The solution seemed almost absurd. Instead of sending discarded oyster shells to landfills, why not return them to the ocean? At first glance, the idea sounded far too simple. How could waste solve a complex environmental crisis? Critics argued the shells would simply pile up on the seafloor. Others feared they would smother existing marine life. Some predicted the entire project would become an expensive failure. But supporters saw a possibility others missed. They understood something important. Oysters cannot grow on soft sand. Young oyster larvae need hard surfaces to attach themselves to. Without that foundation, entire generations die before they ever have a chance to grow. Perhaps the missing ingredient wasn't more oysters. Perhaps it was simply somewhere for oysters to live. So the project moved forward, and the shells went into the water. 500,000 tons of them. For months, nothing dramatic seemed to happen. Divers looking at the sites saw little more than shell-covered seafloor. To many observers, it looked like the critics had been right. But beneath the surface, an invisible revolution had already begun. The first settlers weren't fish. They weren't crabs. They weren't even oysters. They were microscopic organisms. Tiny bacteria rapidly spread across the shells. Soon, thin biological films coated every surface. To the human eye, nothing had changed. But biologically, everything had changed. These microorganisms transformed the shells into living habitat. Then came algae, then tiny invertebrates. Then, microscopic grazers. Each newcomer created opportunities for the next. A food web was assembling itself from the bottom up. Nature wasn't waiting for instructions. It was already rebuilding. Here's what made the project so different from traditional artificial reefs. Most artificial reefs are passive. They provide structure. That's it. A sunken ship creates hiding places. A concrete block creates shelter. But oyster shells did something far more powerful. They actively changed the chemistry around them. The calcium-rich shells created conditions that encouraged marine organisms to settle and grow. Instead of merely offering space, they created opportunity. It was as if the shells were sending an invitation to life itself. Every shell became a tiny platform for growth. Every pile became a launch pad for an ecosystem. And soon, the real stars of the story arrived. The oysters. Young oyster larvae drift through ocean currents, searching for a place to settle. Most never find one. But now, suddenly, there were millions of new landing sites waiting for them. The larvae attached themselves to the shells. Then they grew. Then they reproduced. Then their offspring settled nearby. For the first time in decades, the natural cycle had restarted. This was the turning point. The moment the project stopped depending on humans, nature had taken over. Each new generation of oysters added more shell. More shell created more habitat. More habitat attracted more oysters. The system began feeding itself. And as the reefs grew, something else started happening. the fish came back. At first, only a few species appeared, then dozens, then hundreds. Fish that had become increasingly rare returned to the area. Juveniles found shelter among the growing reefs. Predators followed their prey. Crabs moved in. Octopuses established dens. Sea turtles began feeding nearby. Dolphins hunted around the reef edges. What had once been a relatively barren stretch of seafloor was becoming a thriving underwater city. And it wasn't merely attracting existing wildlife, it was producing new wildlife. That's a crucial distinction. Many artificial reefs simply gather fish from surrounding areas. These reefs were helping young fish survive. They were increasing populations. The ecosystem wasn't being rearranged, it was being rebuilt. And researchers noticed something even more surprising. The water itself was improving. Oysters are extraordinary filter feeders. A single oyster can process huge amounts of water every day. Multiply that by hundreds of thousands, then millions, then entire reef systems. The impact becomes enormous. As the oyster population expanded, the reefs began removing suspended particles, excess nutrients, and pollutants from the water. Water clarity improved. Sunlight penetrated deeper. Seagrass beds expanded. And those seagrass beds created even more habitat. One positive change triggered another, then another, then another. The ecosystem wasn't just recovering, it was accelerating. The environmental benefits were impressive, but the economic benefits surprised everyone. Local fishermen who initially opposed the project began changing their minds. Fishing improved. Marine biodiversity increased. Tourism benefited. Charter captains reported stronger catches. Businesses connected to coastal recreation saw new opportunities emerge. The same communities that once feared the project now wanted more reefs. And that shift may be the strongest proof of success. When scientific data and local experience tell the same story, something significant is happening. Then nature delivered the ultimate test. A powerful hurricane slammed into Florida's Gulf Coast. Storm surges battered shorelines. Waves hammered vulnerable areas. Damage was widespread. But researchers noticed something fascinating. Coastlines protected by oyster reefs often experienced less erosion than nearby unprotected areas. The reefs absorbed energy before waves reached shore. Instead of acting like rigid barriers, they functioned like living defenses. And unlike concrete structures, they had a unique advantage. They could repair themselves. A seawall begins deteriorating the moment it is built. A living reef becomes stronger as it grows. That realization changed how many experts viewed coastal protection. Perhaps nature wasn't just something to defend. Perhaps it was one of the best defenses available. Today, the impact of these reefs continues to expand. Scientists around the world are studying similar approaches. Countries facing erosion, habitat loss, declining fisheries, and water quality problems are paying attention. Because the lesson reaches far beyond oysters. The real lesson is about restoration. For decades, environmental problems have often been approached through expensive technology and massive infrastructure projects. Sometimes those solutions are necessary, but sometimes nature already has an answer. The challenge is creating the conditions that allow that answer to work. What happened in Florida wasn't a miracle. It was biology. It was ecology. It was an ecosystem finally receiving the missing piece it needed. And once that piece was restored, nature did the rest. Think about that for a moment. 500,000 tons of discarded shells, a material most people considered worthless, a material destined for landfills. And from that waste emerged cleaner water, stronger fisheries, healthier ecosystems, greater biodiversity, and even protection from storms. It's a reminder that some of the most powerful solutions aren't always the most complicated. Sometimes the answer isn't building something new. Sometimes it's helping nature rebuild what it once had. If you enjoyed this story and want more incredible science, technology, and environmental breakthroughs from around the world, make sure to like this video, subscribe to the channel, and turn on notifications, because the next story might be even more unbelievable than this one. And trust me, you won't want to miss it.